Hey, this is Mr. A, and this lecture is going to be about atomic structure and the periodic table. There is a definite relationship between the Bohr model of the atom and the periodic table. And so far, all that we've that relationship I've only talked about in terms of the really simple atoms. But there are certain rules as to what you do, how you build this model as you get larger and larger elements. These atoms are actually getting bigger and bigger. There's more protons in the middle, there's more electrons going out around the side, and there's a definite way that you construct these atoms, and it's all governed by rules, which I hope to cover in this lecture. And by the end of this lecture, what I want you to know is why there are only 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and electrons in the higher shells or energy levels. These are the points that I want you to remember. We're going to use this as kind of our agenda as how we go through this lecture, and it'd be really important for you to know each of these bullet items. Maybe you want to stop the video at some point and take some notes as I talk about these. The first thing that I want you to know, the periodic table is organized like a calendar. So like a calendar, we have days of the month, 1 through 30 days of the month. We have 1 through 90 elements on the periodic table. They're ordered like a calendar in terms of the fact that we fill up a row, and then at the end of the row we come back and we fill up another row. But if you look at the periodic table, and here's my periodic table, I've got a number 1 up here, and it takes a jump, yes, over here to number 2, but then it comes back to 3, 4, 5, 6, 7, 8, 9, 10, then it comes back 11, 12, 13, 14. It's all in a sequence, and then every periodically it folds back on itself. The periodic table periodically folds back on itself like a calendar does. The atomic number equals the number of protons, and we learned that over the last few lessons. Let's just jump into this and start building some atoms. So if I am building a hydrogen atom, then I know that the hydrogen atom, and I'm not going to draw the individual protons here in the middle. What I could do is I could just say that as far as protons go, there is 1 proton, P1. Or I could just say that this is hydrogen. Because if we could look up on the periodic table and we would know that hydrogen is the first atom, its atomic number is 1, that means that it has 1 proton. And it also has 1 electron. For a neutral atom, the number of protons equals the number of electrons. So we have a proton in the middle. We need to put now an electron out here in this first orbital. Okay, there's a big old dot right there I made trying to represent an electron in the first energy level. These rings around the nucleus are called energy levels or shells. I will use those 2 terms interchangeably. Shells gives you a nice visual, looks like a shell going around the nucleus, but energy level has more meaning in terms of the chemistry. I'm going to use those 2 terms interchangeably. So here's our hydrogen atom, 1 proton, 1 electron. So let's check this off of our periodic table. Helium adds another proton. There are 2 protons in helium, so for a neutral helium atom, we need to have another electron. Now notice I put the first electron in the first shell, I put the second electron in the first shell. When you're building atoms, you always start at the lowest energy level or the shell that's closest in, and that's where you load your electrons in. You don't put them out here on the outer edge. That's just not following the rules. There's chemistry reasons why we don't do that. Suffice to say that the rule is that we start loading electrons in the lowest energy level first. All right, so we have built helium. Now, notice that we're at the end of the row, we're going to have to come back to pick up lithium. Lithium has 3 protons, so it needs to have 3 electrons. Funny thing about this first shell, it can only hold 2 electrons. So that third electron, I'm going to have to actually put in the second energy level. So here's my third electron in the second energy level. Okay, so lithium, 3 protons, 3 electrons. Let's keep building. So I built lithium. Now we're going to go to beryllium. Beryllium, atomic number 4, has 4 protons. Here's my Be. 4 protons means I need 4 electrons. My first shell is already filled, so my second shell is not filled, so I can go ahead and place an electron in the second shell. Very good. All right, let's build. That's beryllium that we have built. Let's build boron. Okay, the second energy level is not full, so I can put another electron in this second energy level. So I've got 1, 2, 3, 4, 5 protons for beryllium. I've got 5 electrons for beryllium. 2 are in the first shell. I've got 3 in this shell, in the second energy level. And I can go on, I think you get the picture. I could do the same for carbon and nitrogen and oxygen, and well, let's do fluorine. Fluorine, atomic number 9. So I've got 9 protons. I need to have 9 electrons. So I've got 2 in the first. 1, 2, 3, 4, 5. Oops, that's too far out, isn't it? Let's see. Here we go. 5, 6, 7, 8. Let me count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 electrons. This is no longer beryllium. If it has 9 electrons, it's going to have 9 protons. This is fluorine. All right? 2 in the first. 1, 2, 3, 4, 5, 6, 7 in the second energy level. That's fluorine. Now, I'm almost to the end of the row with neon. If I'm going to build neon, I'm going to have to change my markers here. If I'm going to build neon, I need to add 1 more electron in this outer level. Neon in the second energy level is now full. Well, wait a minute, Mr. A, let's think about that for a second. First of all, you said the first energy level only had 2 in it, and then that was full. Now we've come around to 8, and now you're telling me that 8 is full. Yep, those are the rules, and that is how the periodic table is laid out. There are 2 elements in the first row. There are 8 elements in the second row. When I've gotten to the end of this row, like the calendar, we've got to come back and start loading on yet another energy level, so that when I build sodium, I now jump out to the third energy level. And as I fill up the elements on the periodic table, I am going to be loading electrons in this energy level out here. Okay, so 2 in the first. I've got 8 in the second. I've got 1, 2, 3, 4, 5, 6, 7 in this third energy level. I'm now ready to build argon. Argon is going to add that electron, the last electron, out here in the third energy level. So now this one is full, because when I come back and I build potassium, I have to start on a new energy level. All right, so let's just build these last 2. So here's potassium. Oops. Potassium. That's what potassium looks like, and calcium. All right, so calcium. If you were to count all these electrons, I would have 20 electrons because calcium has 20 protons. In a balanced atom, you have as many negative charges as you do positive charges. This is a balanced calcium atom. Most important thing here I wanted you to catch is that as you fill up a row on the periodic table, you have to come back and start another row. As you fill up a row, then you're jumping to the next energy level when you are filling up the electrons. Some of you may ask, why did I draw the electrons in pairs like this? It's just a convention. When we start talking about Lewis dot diagrams, it'll be an easy transition for you to go just looking at calcium and its the electrons that are in its outer energy level. Those are the only dots that electrons that you will use to represent the dots in the Lewis dot diagram. We'll talk more about that in a second lecture. But anyway, I draw them in pairs because it's really just a convention. All right, let's see where we're at with our list of things that we needed to accomplish today. Electrons are ordered in the periodic table by atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, blah, blah, blah. The atomic number is the number of protons. You know that from previous lectures. In a neutral atom, the number of protons equals the number of electrons. That's how we knew how many electrons to draw. Electrons are located in energy levels or shells. I use that term interchangeably. Electrons fill the lowest energy level first. Always start at the lowest energy level and build outward. Energy level is associated with the period or horizontal rows. I have 1, 2, 3, 4 energy levels shown here. 1, 2, 3, 4 energy levels shown in my scrunched up periodic table here. When the outer energy level is full, the next element will start a new period or row or outer shell. Each group, each vertical column, then this is something new I haven't talked about. These are just make sure you got your head right when we're talking about groups and period in the periodic table. The horizontal rows, a row is horizontal, like the horizon, horizontal row in the periodic table, and then groups or columns in the periodic table. Here's something that is a little subtle, but you need to be able to pick up on it. All of the elements in this column have just one electron in its outer shell. All of the elements in this column of the periodic table have 2 electrons in their outer shell. With the exception of helium, and it has 2 electrons in its outer shell, and it's way down here. But that's an exception to the rule. You're just going to have to remember. All of the elements in this column have 3. All of the elements in this column have 4, 5, 6, 7, 8. All of the elements in the last vertical column or group of the periodic table have 8 electrons, with the exception of helium. We've covered everything that we want to talk about. The last thing that I want to say is that the periodic table that you will see in the back of your book is wider. We are only talking about, in physical science class, elements up to number 20. When you're looking at only those, you don't count all those that are in the transition metals or that are in the middle of the periodic table. So there is a break right about here where you would need to open up this periodic table to make room for all those other transition metals. But since we never get to talking about element greater than 21, then I can compress it just for our purposes here. The reason we don't talk about those transition metals is that the Bohr model kind of starts breaking down at that point, and it's not as easy to talk about those elements. If you want to learn about atomic structure and electron configuration for the elements greater than 20, you're going to find that out when you take chemistry as a junior. But for right now, I hope that you have made a connection between the atomic structure and the periodic table.